Hi, it's Jan Beta and we're going to take a look at a new Arduino-based RAM tester. This one is pretty small and pretty sophisticated. Yeah, this whole endeavor has a bit of a story behind it, and there are a few models of Arduino-based RAM testers that I already covered on the channel, starting with this one, which I just put together with some parts that I had lying around here. It is based on a forum post that I'm going to link again in the video description. Very simple circuit, and it can test DRAMs and does so quite well. And then there were some other iterations. I've shown this one on the channel. That's a dedicated circuit board that's made for the project. That's a bit more elegant. Yeah, basically the same circuit as this, but a bit better made, basically. And then this came out of the whole project. This is still on the same forum. This was sent to me by Andreas, who designed this. This is kind of a new implementation of these devices here with a better algorithm. It can do more types of RAM. It can auto-detect the RAM chips. It has a little display, and we're going to check it out today. Thanks, Andreas, for sending this. I somehow didn't get around to doing this. I think he sent it already last year, sometime last year. And there are several mentions of this in videos and also on Hackaday. I'm going to link that in the video description as well. This actually doesn't need a separate Arduino to plug it in like the old models here. This has an Atmel 328P processor on board. So that's an Arduino processor, and that's integrated in the board. All you need is to plug in USB power and the RAM chips to test them. This thing is a completely open source project, open source hardware, GPL version 3 project. So everything you need to build this is on GitHub. There is a PCB layout with through-hole parts that is the same circuit as this one, but it's easier to build, and that's also available as a PCBWay project. I'm going to link everything you need to build this in the video description. Andreas sells kits for this SMD version, and there's also a little adapter board available that I also have to test even more kinds of RAM chips. So yeah, there's going to be some assembly required for this one because it's the kit that Andreas actually sent me. And we're going to have to solder the few through-hole components that go on this board ourselves. The SMD components are already populated. That includes the processor on this board. That's why it's so tiny. Okay, as I said, there are a few parts to solder in, and it's not much. We're going to do that without talking much about it, but we're still going to have to do it. And we have the possibility of soldering in these pin headers here, or these sockets rather, to be able to test zip RAM, so the zigzag RAM in here. Yeah, the zip RAM was only used briefly, mostly in the early 90s. But as you probably know from watching my channel, the Amiga 3000 and 3000T used zip RAM on their boards, among many other computers of the time, and I guess other hardware as well needed RAM. That was meant to replace the DIP RAM packages at the time. And then they went with the pluggable and unpluggable sticks of RAM that had surface mount RAM chips on them after that. So this was relatively short-lived, and these RAM chips can be super expensive, so it's a good idea to have a possibility to test them before you plug them or solder them into a board. And this device can do that. Yeah, I think that's assembled. I'm going to shorten these leads here a bit for the display. There are some components on here as well, resistor packs and little capacitors. So it's a double-sided board with both sides populated. But that's the little tester itself. Then we have a little adapter board for 4116 chips, I think. Yeah, this is a little adapter board. And we have to solder in some pin headers here as well. This is also available as a kit. So I think it's a reasonably smart idea to solder in the pin headers first on this one. And I'm just going to plug them into this here, I think, to have them aligned properly. Yeah, now we're soldering in the ZIF socket with the lever pointing in this direction, actually. There's a little PDF on the GitHub for the project that tells you what to do. This should be the correct orientation, so let's solder it in. And we have to be a bit careful because we don't have a lot of room between these plastic things that we soldered in before here. It's going to be fine. And of course, you could shorten the pins of the pin headers on the other side a bit to have easier access and have to have these pins of the ZIF socket protruding a bit more, but it's totally sufficient this way actually. It's going to be fine. Yeah, that should be everything assembled. And this is what they look like, both of these. And of course, I'm going to have to pull the foil from a little OLED display here. Yeah. And then there's also a little sticker provided that can go on here to see the correct orientation. Yeah, and as you can see, this is the direction of pin 1. That's the important thing to note here. And the kit also comes with a piece of like self-adhesive foam that you can put on the bottom. But I'm not going to do that just yet. I'm just going to test this with a USB-C power supply. It should turn on without any chip inserted here, I think. And show me the firmware version, which is probably out of date. So we're going to look into updating that in a bit. So let's quickly test our endeavors here. It should power up. Yep. DIP settings, and this is version 3.0.1. I don't know if you can read that. The assembly seems to have worked. That's what I wanted to test. Yeah, we're on the GitHub page for the project, and Andreas is constantly working on this, so the firmware is updated regularly. Current firmware is 5.0.9 that just came out a week ago or something like that. This is a vintage DRAM, SRAM DIY tester, as I said, and it is faster than the other testers, much faster and a lot thorougher in a number of ways. And also it can detect the chip you put in there once you set the little dip switch to the number of pins. That's all you have to do basically. And then insert your chip and test it. And it can do all these DRAMs, 4027, 4816, 4116 with the adapter that I've shown. And it can do 3732, 4532, 4164, 4464, 41256, 44256, 41 1000, 51 4400, and yeah, it is very fast. As you can see here in the test time column, it tests a whole 44256 in 3.5 seconds. The other testers that I've shown on the channel take much longer, and this should be just as thorough, if not thorougher, actually. It tests for ground shorts, it tests for power supply shorts, there's even a fuse on the board, address line and decoder faults, stuck cells or crosstalk via bidirectional checkerboard patterns, random patterns combined with retention time checks, CAS before RAS refresh timer function, and yeah, this is actually better in many ways than the March B tests that most other testers do, the checkerboard tests that this performs. So yeah, it should be a really good tester. And we're going to test the tester in a second. But first we're going to have to update the firmware because it's really out of date, which is entirely my fault because I procrastinated making this video for a long time, even though it is probably going to be a very useful addition to my little lab here. So I think I can stick on the little adhesive thing here on the back now, which is going to make that thing a bit easier to handle. That's the whole purpose of this. Yeah, and it actually makes it feel pretty solid. That's nice. So yeah, as I said, you have to set the dip switch here according to the number of pins your RAM chip has, and then it's going to test the RAM. And as I also said, this has a zip socket here for that zigzag type RAM. I think I have some of those chips somewhere, so we're going to be able to test that. First of all, let's update the firmware. That's a bit of an involved process, but it's not that difficult. There are a number of ways to do this. Yeah, there's a little ICSP header here to program the firmware, and we're going to do just that, but not using a dedicated ICSP programmer, which you can do. There are a number of really affordable models available, but you can also just use an Arduino board. So updating the firmware, we're going to use an Arduino Uno. This is a clone that I had on one of the other RAM testers. We're going to reprogram that, and we're going to use it to connect to the ICSP header here. So I have my Arduino Uno hooked up to my Mac now because I have a more recent version of the Arduino IDE on here, and I also can do better screen captures. So the first thing you want to do is to, of course, download the whole folder with the RAM tester firmware, and we want to turn our Arduino into an ISP programmer, and that's in File, Examples, and then Arduino ISP here. That's our sketch for that. Of course, you want to select the correct device here, and we're going to turn our Arduino into an ISP programmer with this, with the upload button. As simple as that. It should work fine. And that's our Arduino Uno now being an ISP programmer, which is pretty cool. So we can close this again, and this is our sketch for the RAM tester, and we need the library called U8G2. That's this one. I already have that installed, but if you haven't, there should be an install button here. Just install the latest version of that, and we're going to be fine. And yeah, we can see if our sketch actually compiles. Yeah, everything, all the dependencies and things like that are good. So we have to hook up our Arduino Uno to our RAM tester board like this. And yeah, I'm going to do that using some wires, some DuPont wires that I have lying around, and just stick the pins into the ICSP header. So I'm going to see how that goes, but yeah, this is the wiring you have to do. Yeah, you're just doing this with the PDF file, and we're going to angle these slightly so they make a good connection. Just going to use the same colors here to not get too confused. Our little RAM tester is now powered via the Arduino, via the ground and 5-volt pins here. And we should be able to program the firmware like this. I'm probably going to hold these wires a bit at an angle because I just stuck these kinds of cables through the holes there. But usually that makes a good enough connection. It doesn't take long. So we're going to be able to use the Arduino IDE to use the Arduino as an ISP programmer and program our software. We're going to see how it goes. We need to choose our Arduino as a programmer in the programmer thing, programmer menu, tools, programmer, Arduino ISP. That's our Arduino Uno. So the sketch menu, upload using programmer. And that should be everything we need to do to program this. Let's see how it goes. If it fails, that's not a big deal, usually. Just going to hold my wires here a bit at an angle while doing this. Let's see. Didn't work. Let's try again. Cannot find USB tiny device. Okay.
1 million, zillion, jillion, dillion, cotillion times later.
Okay, I finally figured out how to program this and we're now running the latest firmware. I thought I was doing something super stupid, but I followed the instructions and it turns out they didn't work because something in the Arduino IDE seems to be slightly broken regarding the programming using the Arduino as the programmer. Let me show you in detail. I did everything the same as I've shown you on macOS, so I'm not going to capture the screen here again. The thing that actually worked now, all the settings and preparation are the same, but I chose the option Arduino as ISP as the programmer and not Arduino ISP. Arduino as ISP. And that worked. I don't know why, but the Arduino IDE just didn't see the Arduino with Arduino ISP. It kept complaining about not being able to connect to USB Tiny. I'm not sure if there's some script that is damaged or something like that. But anyway, this works, or it worked for me at least, so maybe that works for you too. I didn't damage anything, and it's really difficult to damage something unless you short something out or something like that. But even then, the little board has a fuse, so it should be fine. And you can reprogram it however often you want. Yeah, and I used the Linux box because I thought I was going crazy. But yeah, this is now performing a self-test. I'm going to power it properly to show you. This is the latest firmware and everything worked as it should. And the flashing actually took a while, took a minute or two. So I held the wires in these. You can also solder in wires, as I said. This should now perform a self-test on boot up basically. And it's version 5.9. So yeah, no shorts found. So I have a fun little collection of bad, mostly empty RAM chips that I use to test RAM chip testers. Just going to, we have to set this up to the correct pin count. These are 1, 2, 3, 4, 5, 6, 7, 8, 16 pins. So we just putting the 3/3 switch on the DIP into the on position, the other ones in the off position, inserting our chip, and it should auto-detect, if this RAM is not completely damaged, it should auto-detect the type of RAM. And it has a ground short. Okay, so this one is indeed completely broken. Do that again with another one. Another ground short. Yeah, these were completely shorted. Would be interesting to find one that isn't completely shorted, because this tells you quite a bit about the broken RAM chips. Yeah, but it has ground shorts on different pins at least. Yeah, these are legendarily bad, these MT4264s. As you can see, these are the broken ones I just kept for testing things. Let's test something that's actually healthy. I have some 4164 RAM. That hopefully is good. I'm going to ground myself before I touch these because the old RAM chips are pretty sensitive. So this is actually MT, that's supposedly good. Let's see. 4164. Yep. And that's how fast it is. It's actually super fast. That's quite impressive. That's some MT RAM. Same chips as before, but this time... Oh, this one says defect. Okay. Didn't make good contact, I guess. Yep. That one is also good. These were tested in the Retro Chip Tester Pro. And they all read as good in there. So I suppose these are actually good MT RAM chips. So I'm going to keep them in my good stash here. Now for static RAM, I have some 2114. These have more pins. These are 18 pins. And for these, you have to put them in reverse. So set this up for 18 pins, and these have to go in here with pin 10 facing here. These are 9 pins and 10 is this one here. And the notch of the chip is actually facing downwards, but there are 2 pads open here. So this should detect as 2114, hopefully. Yeah. And it's actually good 2114. Nice. Also Tesla brand. I like these chips a lot. Yeah, this is really quick actually. This is cool. So I have some 41464. Let's put that in there. And it's also 18 pins. Yeah, that's the same as 4464. And it also reports as good. This is actually pretty cool because it's so fast, and also the auto detection makes things so much easier than on other testers. Let's see if I have something else here. Yeah, and it reports back even the address line that is broken. That's address line A0 on this one. And this can do a lot of chips. This can also check the Amiga RAMs that were used in the Amiga 500s. This has a ground short again, but it reports the ground short. That's pretty neat. It's really neat. Do we have something else? A broken 41464. So that's an 18-pin chip again. Doesn't detect RAM. Yeah, no, that's completely broken. Too broken to register. Oh, this has a short on pin 15. So this is really informative, even though it doesn't make... It's not really important what is broken. If a RAM chip is broken, usually the machine just won't start up or behave badly. So it doesn't really matter what is broken, but it's really neat that this reports the actual thing, if it can detect it, that is bad. So yeah, really impressed with this. Yeah, I don't have any more broken or healthy RAM in this parts bin, but I'm going to look at my Amiga chips. I should have some RAM, some Amiga RAM in there. So as it turns out, I have quite a bit of Amiga 500 41256 RAM here. Yeah, this is a 16-pin chip. And these should all be good, actually. And it takes a bit longer for these because these are larger, more memory on these. Yeah, that's a good one. Yep. Really neat. So yeah, these, I suppose these are all good. I tested these before and they all reported good. Now we have something special. I have exactly 2 of these zip RAM chips here. These are supposed to fit in here. And this is a 20-pin chip. Or 19 pin, you can put them in there. This is the 20 pin one. Yeah, this takes a while. Yeah, and that's a 514402 chip. Nice. You can't, of course, you can't put a zip RAM in here and another RAM in here. It's going to be confusing the machine here. But you can totally test these in here. That's pretty neat. I don't have anything else that can do that. I think you can do that with the Retro Chip Tester Pro if you get an expansion module for that. But yeah, I don't have that expansion module, so this is going to come in handy for testing these. Super impressed with this, I have to say. This is pretty neat. And if you put them all into the off position and reset it, you're getting the little self-test that actually tests the board. And the QR code here, if you scan that, takes you directly to the documentation in the GitHub. So yeah, this goes in here like so. Oh, I have to set it into 20 pin mode. So now I can test this. Yep. That's good. 4116. And the other one, that's the two I have remaining. Yep, that's also good. Nice. Okay. So this adapter board also works, but you need to set up the device in 20 pin mode. And one thing that no other tester I know of can do is that this can actually test the 4164 RAMs that were half broken that were used in the ZX Spectrums. Some of the ZX Spectrum 48Ks, I think, used half broken RAM chips for the upper RAM, different variants of these, and this can test all of them. So that's a pretty neat feature in case you're working with ZX Spectrums. That's one feature that I didn't see anywhere else, basically. I'm not sure if any professional testers can do that kind of testing. I am really happy with this. And as I said, Andreas is working constantly. The last firmware update was just a few days ago. So this is updated all the time. You can build your own. It's all open source. You can modify it if you want. But that is a bit fiddly because the timings, of course, are very delicate. So if you modify the software, this might stop working correctly because of the delicate timings. But the software seems to be really nice already as it is. There is also a little settings mode, I think, in the newer firmware versions where you can actually modify some settings, which is pretty nice. All dip switches to the on position, no RAM chip in there, and it should go into setup mode, which it does. Yeah, and here we have the functions on the 3 dip switches, which are directly saved to the flash ROM, so you have to set them the way you like with the dip switches and then reset or just turn it off. The settings are going to be saved anyway, so when you start this up again, these are going to be the same settings you set. So we have dip switch 1, which is the 32K enable. That means that it's for those half-good 4164 chips. If you don't need that, you can switch it off, so half-bad actual 4164 chips are not going to be interpreted as 32K chips. The dip switch 2 is to access a loop mode in case you want to stress test your RAM for longer periods of time. You can activate that and it's just going to test them over and over and over again until you reset it. And dip 3 is for a dimmer display. You can switch the display to a dim state in case you want, for example, to run this for a long time or do the loop testing, because these OLED displays are going to burn in at some point if you don't dim them. yeah, not much more to say. I'm super happy with this. It's really quick, it's really small, so I can just keep it around my bench here and quickly test stuff. And supposedly this is really accurate. The chips I tested, the bad ones tested bad, the good ones tested good. And I separated all those chips, testing them with the Retro Chip Tester Pro, which is much larger. It can do a lot more chips than this can do. Also different logic chips and things like that. But this is super handy for just quickly testing RAM. This is much quicker, much smaller, much easier to use because it has the auto detection. You just have to set the pin count on the little dip switch. Yeah, really cool project, and also really cool that this is fully open source and you can build your own. And if you know enough about these things, modify it to your liking. Yeah, thank you very much, Andreas, for making this available to the community, and thank you for your time. Hope you found this informative and maybe even a bit entertaining. Special thanks, as usual, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are in the video description and on my website. And if you liked this, maybe consider subscribing to the channel, because YouTube changed the algorithm and things are not going as smoothly for smaller channels like mine as they used to. So that would be much appreciated. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.